Hello, everyone. I'm Maya,
I'm Jonah.
And I'm Hannah.
and our solution for the Search for Solutions team project is concentrated solar power. So, what concentrated solar power is it's concentrating heat from the sun into one point, which produces steam and then supplies energy, and that can be stored to be used whenever there's a lack of solar radiation. Um, So we think that we should use concentrated solar power in our homes and in cities and use it as a substitute for like energy. And it is a carbon-free in a carbon-free manner. And it creates renewable energy, steam, and electricity. So how it works and like the science behind it, it in the beginning it uses mirrors to concentrate the sun's energy, which drives steam turbines or engines, and that creates the electricity. Like more in depth, the curved mirrors focus the energy into a receiver tube where high temperature heat transfer fluid absorbs the energy, which then heats water and produces steam, and that steam is used to power the steam turbine convention system. And when that is turned, it produces electricity and power. And it can also produce thermal energy, which can be stored for later to produce electricity whenever there's not a large amount of solar radiation.
So the way that we think that concentrated solar power can address global issues is that in regards to resiliency, unlike traditional solar panel systems called photovoltaic systems, it can be stored even, so meaning that when the sun isn't out, we can still get energy from it. And this is really important when it comes to integrating energy into a power grid. And so regarding the impact reduction it has, is that in general it doesn't really have any harmful byproducts that most energy methods do. It generates no carbon dioxide, produces no mercury, sulfur dioxide, or nitrogen oxides, or arsenic, doesn't produce any of the harmful byproducts that are associated with nuclear energy, and doesn't have any potential water pollution risks. In regards to efficiency, compared to current traditionally environmentally friendly energy sources, it's not the most efficient, with wind turbines reaching up to 59%, hydropower up to 90%, and solar panels reaching 14 to 23%, which is the most similar to CPS facilities. This is just a diagram depicting the most efficient forms, with solar panels being practically equivalent to CSP facilities. But the important thing to remember here is that CSP is currently being developed, it's currently being worked on, and therefore the efficiency is predicted to go up in the next few years, hopefully. So the benefits of concentrated solar power is that the energy it generates is fully based on the sun, and in that sense it's completely renewable. And also, like any form of energy, it does require like man-made assistance and man-made materials, but for the most part it's pretty sustainable. The most important factor with CSP facilities is that they require large areas for solar collection, and this photo just demonstrates how it comes together. So there's like a solar field, which has, as Maya explained earlier, the mirrors and the support structures, and then there's a thermal storage unit, which again, as Maya explained, is like where they can store everything, and then there's a power block, which has a turbine, condenser, superheat pump, and basically the cooling systems for the whole facility. So another benefit is that the concentrated solar power has a global capacity of just under 5.5 gigawatts in 2018, and overall it just reduces the negative impacts of energy production on the environment because of the lack of harmful byproducts. And so this right here, a linear Fresnel system, is one form. As in an earlier photo, you could have seen a diagram where it's like a circular form, but here it's just like a straight line. So it basically shows how CSP systems can be set up to be most efficient based on the land that they're occupying. And this graph shows where the most concentrated solar thermal power, the global capacity by country and region. So as you can see, Spain has the most, and that's definitely based on the geography of the country.
So how do we implement concentrated solar power into our system? Well, the good news is that concentrated solar power plants are already in practice in several countries, most prominently in Spain and in the US, but those are by no means the only countries where they are in use. Places like China and Morocco are using them and, in fact, getting more and more CSP plants. However, they're not as prominent as they could be. There was some stalling in the progress of CSP technologies in 2008 because they were lacking in funding. 2008 is when the recession hit, so people didn't see it as important or financially sound as some other forms of power. However, they have become more popular recently because costs have reduced since recently more research has been done. And they developed the ability to store power in CSP plants. So it's not only producing power during sunlight, it's producing power all the time. Well, not producing power, but it can release power into the grid at any time rather than just during sunlight. In fact, the cumulative installed capacity from 2010 was around 1,000 megawatts, and now it's over 5,000 megawatts. So it is gaining prominence. Spain is even considering allocating it 5 more gigawatts for the upcoming decade for its total energy consumption. So concentrated solar power is not a perfect solution. For one, it only actually generates energy during the day and only during places with high sunlight. As you can see from this chart, the only real places that you can make a good CSP plant that will generate a lot of energy is in the Southwest or maybe in Florida. The Northeast is completely out of luck, so it's only useful in some areas. I doubt you could use it in places like Canada at all. On top of that, it's very expensive to produce and it takes up a lot of land. The SEIA thinks that it takes about 5 to 10 acres to produce 1 megawatt from a CSP plant. On top of that, it also has the same criticisms as regular solar panels. The production of solar panels creates a lot of pollution and it heats up very fast. It can even burn local wildlife, including endangered species that may be unfortunate enough to come into paths with them.